Hello everyone. This video is designed for class 12 student physics chapter 1. The name of chapter is electric charge and fields. So we will discuss about electric charges and fields. How charges and fields are related with each other. And this lecture will deals with all the concept related to the class 12 NCERT physics and HC Verma. I will also discuss numerical and theory portion also. I will follow only two books, NCERT and NCERT and HC Verma. Resnick Holiday, some portion I will also touch with the Resnick Holiday. So this class lecture will deal with the student, those who are preparing for class 12 as well as for engineering and medical students. So let us start. The very fundamental concept about the charge, electric charge. Question is, what is electric charge? Electric charge. Historically, the credit of discovery of the fact that amber rubbed with wool or silk cloth attract light objects goes to the Thales of Miletus, Greece around 600 before Christ. Means before Christ, 600 years before Christ, the concept of charge was introduced by the scientist that is called Thales Miletus. He belongs to Greece country. When a rod is rubbed with a silk, the rod acquires one kind of charge and the silk acquires the second kind of charge. When rod is rubbed, suppose this is rod, and if it is rubbed on the silk, this is silk suppose, so rod and silk get different kind of charges. This is true for any pair of objects that are rubbed to be electrified. This is true for every kind of object that are rubbed to become electrified. Now if the electrified glass rod is brought in contact with the silk with which it was rubbed, they no longer attract each other. Suppose if we rub these two and after some time if we bring it, it will not attract each other, means the uh, effect of charge is finished, means no charge is present and the effect is reduced. Some more definition is about the conductor and insulator. Some substances they readily allow passage of electricity through them. Easily we can pass. Others do not. Those who which allow electricity to pass through them easily are called conductor. Those element or substance which allow electricity to pass easily are called conductors, like silver, iron, gold, etc. And so many other elements are also there. They have electric charge electrons that are comparatively free to move inside the material. Means conductor has free electrons, like aluminum. If you consider, there are 3 electrons in outermost orbit. They are very freely moving. Metals, human and animal bodies and earth are good conductor. These are the some other example, like metals, these are metals, silver, iron, gold, etc. These are the metals. And animals bodies, human body also are, and earth are also conductors, means they can pass electricity easily. Most of the non-metals like glass, these are the non-metal: glass, porcelain, plastic, nylon, wood, offer high resistance to the passage of electricity through them. They are called insulators. So this is the definition of conductor, is two, and this is the definition of insulator. There is also third type of element that we will study in another chapter, that is called semiconductor chapter. There is a third category called semiconductor, which offers resistance to the movement of charge, which is intermediate between conductor and insulator. In semiconductor, the effect of resistance to the flow of charge is intermediate, means it is somehow higher than conductor, means its resistance is higher than conductor but less than insulator, means if we higher than conductor but less than insulator. The conductive property of the uh, semiconductor is in such a way that the resistance of semiconductor is more than, if we, here I am writing semiconductor resistance, its resistance is more than conductor resistance, but semiconductor resistance of semiconductor is less than insulator resistance. That is why it is in between conductor and insulator. Now, how we get what is meaning of induction of the charging by principle of induction. Suppose this is two ball, two ball, they are very close to each other as shown in here, A and B, and they are placed on an insulating stand. These are the insulating stand. Insulating stand. Stand. Both have neutral. There is no charge showing in this because any element which has same number of neutron or proton, they are neutral. That is why it is called neutral. There is a no charge separation, so charge is not showing here, and they are neutral. Now what happened when a charged rod, suppose it is positive, is brought very near to a sphere A, very near to ball A. What will happen? This ball is neutral here. You see this ball is neutral. Whatever positive charge is there, same charge, negative charge is there. So this ball is neutral. So what will happen here? So this positive is being here. So what will happen? The positive charge of this ball will be repelled. The positive charge of this ball will be repelled by this positive charge. Repulsion force will be there. Positive charge repel each other, and negative charge will accumulate here. Means negative charge will be here, and positive charge will be, suppose here I am just giving an example. Positive charge will be here, and a negative charge is here. For this sphere, what will happen? The same case will be happen. So negative charge will be here, and positive charge as per the repulsion goes here. So these positive negative cancel each other. That is why here charge is not shown. So now let us see what will happen. This that is why it is not shown here. So this negative and positive cancel out. So here negative and finally positive charge will accumulate here. The now what this sphere is separated out, not for long distance, for a small distance it is separated out for a small distance. So negative charge is here and positive charge is here. Finally, this source of charge is removed. It is found that now this positive charge will come here and the negative charge will come here. negative charge will come here due to the positive negative attraction. And finally, redistribution of charge, negative will be here and positive will be here. So this is called the charge through induction, because there is no any contact between these two elements, no contact, no contact between these two elements, although charge is induced here. So this is called charge through induction, means there is no any touch between these two elements and charge is induced. So this is called charge through induction. This is called charge through induction. Charge through induction means no physical connection, no physical touch. Without physical touch, charge is being produced. So this is called charging by induction. Now a very important question I want to discuss here is very interesting question. This question is that how can you charge a metal sphere positively? How can you charge a metal sphere, this is a metal sphere, positively without touching it? We do not have to touch it and we have to give it positive charge. How can we do? This is very interesting question here. Without touching and we have to give it positive charge. So let us see how can we do like this. Suppose we bring here a plate of negative charge near this sphere. What will happen? This sphere has positive and negative charges, positive charges, negative charges, and both are equal. So this atom is neutral. This is neutral. Neutral. Neutral means no net charge. Neutral means no net charge. Charge is neutral means no net charge. Charge is not available. So here it is shown that there is a no charge on this sphere because positive and negative are equal. Positive charges are at the proton which is present in the nucleus and electrons are moving outside. So net charge is 0 on this case. Now when we bring a negative charge here, what will happen? This negative charge, this is neutral, but it has positive and negative charge of equal magnitude. Suppose here 10 positive is there, 10 negative will be there. So net charge is 0. Means if 10 positive is there, 10 proton is there, there will be 10 electron. So this electron or proton cancel each other. So this proton and electron cancel each other, but this plate has negative charge. It is brought here. So the negative charge of this metallic sphere will be repelled by this negative charge and it is separated here and positive charge will be attracted here. This is the one situation. Now what will happen? Now the sphere here where negative charge is available, it is grounded here, means take a wire and connect to the earth, ground. Now what will happen? This all negative charge will go through the ground and only positive charge will appear here because of this plate attracting this positive charge. Now remove this ground. When you put ground here, all the negative charge will go here, and once you remove this sphere from the grounding, the situation will be like this. Now if you remove, because now it is attracted through the negative charge, and when you remove this negative plate far away from here, the redistribution of this plate, positive charge will take place. So we get here positive charge as per our question. How can you charge a metal sphere positively without touching it. I have not touched it, this sphere, and the sphere has got positive charges. Some basic properties of the charges. What are the basic properties of charges that I will discuss here? Basic properties of charges. Let us see here. Charges had additive property. Charges had additivity of charges. Charges add up like a real number, or they are scalars like the mass of a body. As a charge is a scalar quantity, same in the case of the mass of a body is also a scalar quantity. So we can directly add them. If a system contains n charges, q1, q2, q3, qn, then the total charge will be q1 plus q2 plus, because charge is a scalar quantity, so directly we can add it. Charges has magnitude but no direction. Similar to mass. Mass also has no direction, so charge has also no direction. Mass of a body is always positive, whereas charge can be either positive. This is the difference. Mass is always positive, but charge may be positive or negative. Mass is always positive. It is never negative. Mass of anything is never negative. It is always positive. But this is the biggest, very big difference between mass and charge, is that a charge has negative as well as positive value, but mass has only positive value. Another is charge is conserved. What is it meaning? The charge is conserved. What does it represent? It is not possible to create nor destroy net charge carried by any isolated system, although the charge carrying particles may be created or destroyed in presence. This is a very interesting thing. It is not possible. We cannot create or destroy net charge carrying by any isolated system. This is the isolated system. Whatever charge it has, we cannot destroy it, or we cannot produce charge. We cannot, of an isolated system. Although charge carrying particles may be created. Charge carrying particles may be created or destroyed in a process. But for an isolated system, we cannot. Suppose this is example of aluminum. This aluminum has, in outermost orbit, 3 electrons are moving. So these 3 electrons are moving. Inside also there is one orbit, it has 8 electrons. So 3, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are in this orbit, and its nucleus has 11 proton, and here 11 electron. So this element as a whole, as a system, it is a neutral. We cannot create its charge by doing something, but we can do what we can do, although the charge carrying particle may be created. But here, if we remove these 3 electrons, then aluminum has 3 positive charge. But this is the case where electron is being removed, so this electron must have to go somewhere. So the place where this electron is going, that becomes negative. Suppose if I write here the chlorine is there, so 3 chlorine can take these 3 electrons. 3 chlorine can take these 3 electrons. So 3 negative charge will be there. So as a whole, if I talk, so 3 negative and 3 positive charge cancel each other. So we cannot create a charge of isolated system. We cannot create, but for a particle we can create. Here, 3 charge is taken out, so it becomes positive. 3 is taken, this is negative. So as a whole, if you see, there is no creation of charge. Sometimes nature create a charged particle. A neutron turns into proton and electron. Neutrons can be broken into proton and electron. The proton and electron thus created have equal and opposite charges, and total charge is 0 before and after. So when neutron is broken, goes into proton and electron. So here the charge is 0. Here still proton has one positive charge, electron has one negative charge. So there is a, after breaking, its total charge is again 0, as before its charge was 0. The total charge of an isolated system is always conserved. So total charge here of an isolated system is conserved, means it does not change. Next is quantization of charge. What is the meaning of quantization of charge? All free charges are integral multiple of basic unit of charge denoted by E. So E equal to Q into N into Q. Q equal to charge is denoted by Q. N is the any integer positive or negative. The fact that electric charge is always an integral multiple of E as term quantization of charge. Means if you want to get the charge, N will be here, maybe N 1, 2, 3, positive plus minus. But N will not be equal to 1 by 2 or 1 by 4 like that. Means it will be only integer. So charge is quantized, means it is an integral multiple of E. So this is the meaning of quantization of charge. The fact that electric charge is always an integral multiple of E is termed as quantization of charge. This is the called quantization of charge, means integral multiple of E. Whenever we get the charge, it will be integral multiple of E. It will not be a fractional multiple of E. Charge on an electron is 1.60219 into 10 to the power minus 19 coulomb. One electron has this coulomb charge. Suppose if we want to get minus 1 coulomb of charge, how many electrons we need? One electron has this much charge, and there are about 6 into 10, 6 multiplied by 1018 electron in a charge of 1 coulomb. So for number of electrons, if we want to find how many electrons are needed, so 1.602192 into 10 to the power minus 19 coulomb equal to 1 electron. So 1 coulomb equal to 1 divided by 1.602192 into 10 to the power minus 19. If we divide it, then we will get this 6 multiplied by 1018 electron. So this much electron is needed to produce 1 coulomb of charge.